function. They're just not real. They don't really produce a real zero. All right, number 6. Let's try this one. So it's the usual. Step number 1 is to graph it at Desmos, at desmos.com, and find a clear zero. What do you see? Well, this is -1, -2, -3, -4, -5. Boom, right there at -4, huh? Clear. That's a clear zero. And in fact, that's the only place that the graph hits 0. So we know that the other 2 zeros are going to be imaginary, aren't they? They're not going to be real. There's no other real place. There's no other real 0. That's the only real 0. The other 2 are imaginary. We can see the answer right there already. They are. See, they both have an I in them. They are both imaginary, the other 2. We already know that from the graph. There's only one real 0, -4. So we start with that one. That's the clear, obvious 0 from the graph at desmos.com. Step 2, divide that in there to find the other ones. So we're going to divide the x equals -4 into our function. Let's grab the coefficients. 4, -36, and 48. All right. Bring it down, 4, and let's do our first multiply. -4 times 4, -16. Add them up, -12. Let's do the next one. Multiply. -4 times -12 is positive 48. 48 minus 36 is 12. You know what's going to happen on the last one. You really don't have to do it. You can just skip it if you want to. Right? When you multiply there, -4 times 12 is -48. Remainder 0 again, of course, because x -4 really goes in. It's a real 0. It really goes in there. Okay, so now what do we have? We know our function is, what are the coefficients? 4x squared minus 12x plus 12 and x plus 4. Remember? Opposite, whenever you take an answer and you put it in parentheses next to an x, a single number in parentheses next to x, it's always opposite of the real number it is. So x plus 4. Okay, so we're there. We've broken down the function to these two guys. If I multiplied these out, it would go back to be this original function. We're breaking down the original function and finding the zeros. It's all the same thing. Now, got to do the quad. As you know, it's quad time. Let's do it. (b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's going to be, let's see, negative. This is a, b, c, negative 12, b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay. Simplify 2 negatives. You know the deal. Positive. -12 squared is plus 144 minus 4 times 4 times 12. Use your calculator. I'm going to use my calculator. 192. All over 2 times 4, 8. And so that's 12 plus or minus the square root. Kind of running out of room here. Maybe I better try to squish it a little better. So this is 12 plus or minus square root of negative. What's 144 minus 192, minus 48. Right, it's coming out negative in the root. So remember, what do we do with a negative inside of a root? We grab it and throw out an I. It means it's imaginary. It's not real. You can't take the square root of a negative number. So now we bring it over here. We have 12 plus or minus I root 48 all over 8. Now, right, we got the negative out of the root. It comes out as an I to the front of the root. Now, how do you break down the square root of 48? Well, you remember I'll go up here. Square root of 48. That's going to be 6 times 8. That's 2 times 3. 2 times 4, and the 4 breaks down 2 times 2. So 2, 3, 2, 2, 2. So square root of 48 then is 4 is a 3 and 4 2's, isn't it? See them all there? 1, 2, 3, 4 2's and a 3. Okay, and let's ship it out there. So square roots are a 2-for-1 deal. 2 2's inside, 1 2 outside. 2 2's inside, another 2 outside. 2 times 2 outside is 4. What's left on the inside? 3, right? Because that's all that was left on the inside. So, because when the 2 2's send out a 2, they're gone, and those 2 2's multiply on the outside to be 4. So it's 4 root 3. So this becomes 12 plus or minus I times 4 root 3 all over 8. Okay, now, how do we simplify that? Well, remember what we talked about. Any numbers outside the root, you can divide them if all three of them, so this guy, and this guy, not the 3 that's in the root, right? That's a different world. Just the 12, 4, and 8, those 3 numbers that are outside the root, because of this Costco glue here, we got to do both of the top with the bottom. So it's all 3 or nothing. Are they all 3 divisible by something? Is there some number that goes into all 3 of those? If so, we can do it. In fact, we must. Otherwise, we can't. So is there a number that goes into all 3 of those? Yeah, 4. Divide by 4 leaves a 1. Divide by 4 leaves a 3. Divide by 4 leaves a 2. I divided them all by 4, didn't I? Let me do a better job on this one here. So I divided them all by 4. So that leaves 3 plus or minus I times 1. Let me write that better. I times 1 times root 3 all over 2. Right? And now let's separate it. This 1, I times 1 is just I, right? Multiplying by 1 doesn't do anything, so I'm going to ignore that. My 2 separate answers are 3 plus I root 3 all over 2, which is the same as this answer up here. If you come up here, this right here, that's the same thing. You can separate that 2 underneath each one, or just keep it as one big fraction. 3 minus I root 3 all over 2. That's the plus and the minus option in the middle. And the answer from the beginning, negative 4. Negative 4. There's the negative 4. There's the 3 over 2 minus root 3 over 2I. There's our 3 answers. You can enter it either way. You know, one big fraction, or 2 separate fractions, 2 separate fractions. It doesn't matter. It's all the same. There's our 3 answers. That was a tough one. There we go. Okay, so number 7. Looking here at number 7. They want us in the end to, it's basically